Okay, so this video is about discriminants or it's about regression and applications of quadratics. So rocket shot in the air, altitude is that, after p seconds given by that function right there. So first question is, and you can do this with Desmos, I'll pop Desmos up in a moment, it says, in how many seconds does the rocket reach the maximum altitude? So what you have to think about is, the rocket is shot from the ground, it goes up, it comes back down again, okay? So where is the maximum height? It's going to be the vertex of your parabola, okay? So you have two ways to find the vertex of your parabola. You have a formula, so the x value, so this is going to be t comma h, that's your x value and your y value. T, to find the x value of your vertex, is negative b over 2a. So in this case, your time is going to be, b in this case, is negative 128, all over 2 times negative 16, which, be really careful when you're putting this in your calculator. I'll show you really quickly. So, I'm going to put negative 128 divided by, and when I do 2 times negative 16, I put it in parentheses, okay? Sorry, negative 1,6. I put it in parentheses and press enter, and that gives me an answer of 4. If I don't put that 2 times negative 16 in parentheses, I'll show you what happens. So you do negative 128 divided by 2 times negative 16, and you end up with a completely different answer. This doesn't make sense in terms of a problem, okay? Because rockets are pretty fast, they're going to hit the maximum altitude pretty quickly, so just be careful with that. Alright, so what's the rocket's maximum altitude? Again, like I said, you have a couple of options. You can plug in your x value here into the equation to find your y value. So you can plug in your 4 seconds into t right here. So you have your original is h of t is equal to negative 16 t squared plus 128 t. So h of 4, we want to know what time is 4, would be negative 16 times 4 squared plus 128 times 4. And so, 16 times 4 squared. And so that's going to be a total of 256 feet. Okay, so you have an alternative. You can actually graph, so you can bring up Desmos, because you will have Desmos for your test, and you can put in, okay, we have negative 16 x squared, remember you never put in t, plus 128 x, okay, and there's a home button here, and I'll zoom out. Okay, and if you touch this point right here, you have 4,256. So Desmos will tell you your maximum point. Okay. So going back to review. If the rocket, so you have Desmos where you can use the formulas. I pretty much know that most people use Desmos, which is fine. If the rocket did not explode, when would the rocket hit the ground? Okay, so when would the rocket hit the ground? That's always when your height is equal to 0. So we use our same equation. It's going to be, I know that this is when negative 16 t squared plus 128 t. When is that equal to 0? When does it hit the ground? Because you're replacing your height with 0. Okay, and you can use factoring. It's a lot easier than the quadratic formula here. I know that the greatest common factor is going to be negative 16t. This ends up just being a t. Negative 16 goes into positive 128, 8 times, negative 8 times. And so now we know either negative 16t is equal to 0. So I divide by negative 16, divide by negative 16. And so t is equal to 0. Of course, that's where the rocket started, right here. Okay, or I have t minus 8 is equal to 0. I add 8, t is equal to 8. This is where, if the rocket landed on the ground, that would be the other point that I was looking for. You can also use Desmos. If you touch where it crosses the x-axis, I have 0, 0, and I have 8, 0. So Desmos will give you the same answer for that question. Okay, so D says if the rocket explodes 5 seconds after launching, at what height will it explode? So we think about what we're being given, the 5 seconds. Is that time or height? So that's actually equal to time. So you can just simply plug in 5 in for t. So it's going to be negative 16 times 5 squared plus 128 times 5 is equal to your height. And you put that all in your calculator, okay? And you end up getting 240 feet. Okay. For this problem, you can also use Desmos. Okay. I can actually pull up, you press settings, and you go to table, and I want to know at 5 seconds. So I change this negative 2 into 5, and it tells me, like I said, in our table, it says that it is 240 feet at 5 seconds. Okay, last question. It says, if you wanted the rocket to explode at a height of 200 feet, how many seconds after launch would you need it to explode? This one gets to be a little bit more complicated. So your height is 200, so you're going to replace h of t with 200. So I have negative 16t squared plus 128t is equal to 200. Now we have a solving problem. When you solve a quadratic, you set it equal to 0. So the first thing I'm going to do is I'm going to subtract 200. So it's negative 16t squared plus 128t minus 200 is equal to 0. You could use graphing for this, but for this particular problem, you're going to use the quadratic formula. So you're going to do t is equal to negative 128 plus or minus the square root of 128 squared minus 4 times negative 16 times negative 200 divided by 2 times negative 16. You can throw all of this in your calculator. Good.